22 edition of the meetup. My name is Darius, together with Radu and Bianca, we're the organizers of this event. And I just have a few practicalities to share with you before I hand it over to our speaker. I should speak louder. Okay, or I can also come a little bit closer. My name is Darius, with Radu and Bianca, we're the organizers. I just have some practicalities to share. First of all, the drinks are behind you. We have sodas, we have beers, and also we have water. We have some taps behind. Food will be served after we have the presentations, just behind the screen over there, we'll fix it. There's restrooms right around the corner. You'll find it in the corner over there. And stick around at the end of the session because we have some prizes from INTELLISHORE. It's a few PyCharm licenses, right, Radu?
Yes, 4 of them.
4 of them. So we'll have a little bit of a raffle and then we're going to hand them out to the people here. So don't leave after the presentations. And also, yeah, there's some social part. So right now we have Michel André from Banking Circle to say a few words.
Yeah, hello. This is just a few words from the sponsor. I will keep it very brief. It's good to see you all here and welcome you to Banking Circle. I'm CIO of Banking Circle and we are a European bank started back in 2015 and we got a banking license in 2020. We're equity backed and expansion and provide payment services. And actually, I think in 2018 we started our cloud journey and are now 100% cloud-based, which probably is one of the few banks. A lot of people talk about it, but we are actually there. This year we finally, but we started, it took some time, but we're there now. And this is an data engineering meetup, so this is just to give you a brief glance of the technologies we are using in the data engineering area. I will not go into depth to that. You need to speak to Darius if you want to know more about that. And we are hiring and looking for new talent. So so hand your card to Darius if there is need. But we have 2 exciting speakers tonight. Olivier will start and talk about the real-time data pipeline, and Anders will speak about distributed data mesh architecture. So I will happily welcome you once again and hand over to Olivier that will start and tell about the journey he's gone through in real-time pipelines.
Thank you.
Thank you.
There you go. So I'm Olivier Corradi. I'm the founder of a company called electricityMap. It used to be called Tomorrow. We refocused everything on electricityMap roughly a year and a half ago. And I'm going to talk a little bit about how we run our electricityMap data pipeline in the cloud. First of all, why this company actually exists and what it does. The biggest challenge of our generation, I believe, is climate change. If you look at where our energy comes from, it's mostly coming from those CO2 emitting fossil fuels, oil, gas, and coal. And this is the big chunk that you can see over here. The problem is that climate change is of course caused by these fossil fuels. The second bad news is that it represents over 80% of the energy, and we need to get that to 0 by 2050 if we want to have a chance of reaching the 2-degree target by the end of the century. The second piece is that energy is a representation of everything that we do in our society. It's our ability to move things around in trains. It's our ability to shape things, manufacture, and so on. So basically what this graph means is that we need to reinvent 80% of the way that we actually live, work, create value in general in the society. So not a small challenge. The solution to this, easy, just electrify everything. I think that's what we hear everywhere in the news. The only problem is that we need to electrify it with something that is clean, that doesn't emit carbon. And unfortunately, right now in the world, most of the electricity is generated with these type of things. This is a huge coal excavator in Germany, I believe. It's one of the biggest machines built by mankind. Just to give you an idea of the scale, you have a small tractor here That gives you an idea of how huge this thing is. 20% of global emissions come from coal power plants generating electricity. So much more than flying and cars actually. So electricitymap maps the carbon emissions of electricity generated worldwide, and we do that in real time. I'm going to show you a quick demo of how this looks like. You can access this thing on just Google electricitymap and then you'll find it. This is real-time information, and what this shows you is, so the color on the map represents the carbon intensity of electricity consumed. So if I look, for example, at, here we are, you can see that the number says 162 grams. So it means that if I were to consume 1 kilowatt hour of electricity from the power plug, I would be responsible for emitting 162 grams of carbon in the atmosphere. This number is calculated by looking at how electricity is produced locally. So you can click on it here and you can see that what is interesting right now, here there's a lot of electricity that comes from Sweden. There's almost half of the electricity that comes from Sweden. We have a little bit of coal, the solar, the sun has set, so of course we have a little bit less than solar, but I think it was quite a good day. We had almost 20% solar in the hours before, which is nice. We have a bit of electricity that's imported from Sweden here, which means that if you want to figure out how clean the electricity is in Denmark, you also need to know how it's actually generated in Sweden, and maybe Sweden also imports it from somewhere else, and then you need to sort of go back up the whole chain of imports to figure out how clean it is here. And that's going to be important when we're going to talk about the data pipeline. I think I'll just stop here for now, else I will talk too much. We're going to go back to the presentation. Our mission is to organize the world's electricity data, and we do that to bring a lot of transparency in the world, hoping that we're going to be able to use this information to make better decisions, both as governments, as individuals, and as companies. And in the end, the goal is really to decarbonize that electricity system to make sure we can replace all the fossil fuels with electricity generated with low carbon electricity. One thing to note is that I think this is a cool animation that showcases how these different colors change over time. And you see countries like Spain, Germany, but also Denmark changing quite a lot colors depending on how much the wind is blowing. So these are the wind patterns you can see. And the conclusion of this is that you need to consume electricity when the grid is actually the cleanest. And that's a product that we sell directly to our customers. So Google is using this to optimize their data centers. Now, when you are scheduling some computations in a data center, you actually have a little bit of flexibility. There's a lot of jobs that can wait a couple of hours before being scheduled. So there's a time dimension where you can move the computations to times where the electricity is the cleanest. And now they also do it spatially. So if the electricity is clean in, I don't know, Ireland, but not in Denmark, they will ship the job to it, and the containers to a different place. So this is one use case. Second use case, if you are on Google Clouds, there's a feature called Google Cloud Footprints. You can go in and see exactly what is the carbon footprint of the different services that you use, and we're the ones powering it with the data behind it. So this is actually the carbon footprint of electricitymap in November, roughly 100 kilos of CO2. So I don't know what 100 kilos is. That's roughly equivalent to a very short haul flight. I think 300 kilo would be a like Berlin to Copenhagen flight would probably be 200, 300 kilo as a order of magnitude. It's also since a couple of weeks powering Windows Update, the beta version. So Windows is starting to schedule the Windows update to make sure your computer is using electricity at the optimal time. Just trying things out here. And used by a couple of other, I think the only use case that I will mention else is the one where you optimize the charging of electric vehicles, because it obviously makes sense that when you come home in the evening, plug your electric vehicle, you don't want it to charge right away. Maybe you want it to wait a couple of hours when the wind, for example, starts blowing. So this is also something we're involved in. But let's get now a little bit more technical. The electricitymap data platform has a piece of it at the core, which we call contrib for contributions, which is open source. So it means that all the different countries you saw on the map, there's a little piece of code attached to each of them, which fetches the data from different data providers across the world about the state of the electricity grid. And this is something we open sourced because it helps us gather a community of folks, experts around the world that will help us in sourcing the data and maintaining these things. On top of that, there's a platform which I'll describe in a second. And the use cases is on one hand, the live electricityMap app that you just saw before, the visual representation. On the other hand, we have this API that is used by Google and different apps across the world, where we actually make a living out of it. So going a bit further into the data pipeline, at the bottom...
Can you interrupt for a second?
Yes, of course.
Because we get on the it looks like there's an issue with the stream.
So we can't have that.
And yes. So I'm wondering if you could. Yeah, I think we could share the slides after, right?
Absolutely. Want me to do anything differently or
No.
No?
Sorry for that.
Oh, no. So the electricityMap data pipeline, we start at the bottom. This is the data that we collect, which is open source. So what we collect is production data, how much the wind turbines are currently producing of electricity. What we call the exchanges represent the interconnectors, so how much electricity is currently being imported from Sweden to Denmark, for example. We have some weather data that we use for the forecasting mechanisms and algorithms that we have after. And then we have a bunch of other things that we collect about the power system. This goes into an event database where we mark every data point that we get. So we say right now there's an event that says the wind turbine production has changed to that level. So these are the kind of events we collect. There's a flow tracing algorithm, which I will talk a little bit about after, which is the core of our technology and which figures out where electricity comes from, this whole graph of interconnections. And then we have a forecasting system at the top. We were going to deep dive a little bit into that box particularly. So the challenge is that this whole grid is completely interconnected. So say, for example, that you wanted to figure out where electricity comes from in Spain, then what you would need to do is to look at where does Spain import its electricity from and where does it produce it locally, how does it produce it locally. So we have to go back on this top arrow which represents the electricity import from France. And as soon as we get back to France, we have to look at how France produces electricity. You've guessed it, we also need to look at where France imports its electricity from. And then we go to the UK, to Belgium, to Germany, and we do that operation again. And you sort of continue, and then you might span the whole system. You might even have cycles, because sometimes you have loop flows in the electricity system, which means that you can't just recursively continue because you will never end the recursion if you do that. So what you can do is that you can mathematically formulate this problem, but first we need to put a couple of assumptions in order to be able to model this problem accurately. The first assumption is that the electricity sources, they mix together where they're injected into the grid. So the best analogy that I have here is to say when you are making a smoothie, you put some different ingredients in them, but as soon as you drink from it, you only drink the mix. You can't say like I'm gonna drink only the banana piece of it. Which means that electricity behaves a little bit in the same way. When you have a given area, you will produce electricity, you inject it into the system, it mixes, but when you export it to a different country, then you only export the mix of it. You can't just say, I'm going to keep the good stuff and I'm going to export the bad stuff. Yes, you have a question?
Do you like questions during the talk or at the end?
Come with it. If it's a short one, I'll take it now.
Just wondering about the mix. Doesn't that also depend on what you pay for? So the money that you would pay for supports a certain kind of industry or generation of electricity you represent.
So you can ask me the question again at the end because that's opening a whole topic. But the very quick answer is that there's two ways to compute origin of electricity, and we here look at more the physical representation. There's also commercial representation, which looks at the flow of money. We here more look at the megawatts that are getting exchanged. I can get back to that a bit deeper afterwards. So electricity mixes, when you export it, you only export the mix, and then you have to look at the whole graph of the interconnections. So when you formulate this mathematically, what you can say is, first write a balance of energy equation. Basically says the electricity that's consumed somewhere needs to either be produced locally, so that's the first equation where you see power consumed equals sum of produced plus sum of imported. So this electricity consumed can either be produced locally, can be imported, and then you deduct what's exported. But as soon as you go to the conservation of CO2 instead, what you need to look at is to say, what I'm consuming locally, I will consume it with a certain carbon intensity, and that carbon intensity is what we're trying to actually figure out. That's the color on the map. And that will either be the production multiplied by all the different emission factors for each system. For example, wind emits almost nothing, coal emits a lot, so that's going to be on the first line. The second line is the sum of all the imports, and for each import, we will put the carbon intensity of the other area, because when you import electricity, the dirtiness of that imported electricity will be the dirtiness of the zone you're importing from. And then minus, so you deduct what you're exporting, and when you're exporting something, you're exporting it with your own carbon intensity. And that's the same thing as saying, when I drink from the straw of the smoothie, I get the average, let's say, blend of the smoothie. So here, analogy would be, I get the blend of the dirtiness of the electricity in the current place. This is an equation that you can put in a matrix format. You have one equation per node in this big graph, and when you invert the matrix, it gives you the blue numbers, which are the carbon intensity, basically the color on the map. So what this means for the computation system is that we need to have all the data for all the grids at the same time in order to be able to solve the problem and come up with a number. We can't parallelize it per country, because then we're missing the whole graph of information. Did that make sense? Yes, I see some nodding, good. So, second challenge. The data that comes in comes at very different time frequencies, which means that sometimes, let's take the first example here, you have Denmark, like Western Denmark, could come in at 15-minute intervals. The second row here, Denmark, the eastern part, could come at hourly level. Sweden could come at 15 minutes. And we could have Germany that even comes in like non-periodic, because it would only be when we probe the system that we can get a data point. So this is a mess, and this is actually a challenge that is quite annoying to solve. So the question is, how do we do it? The first step is to align all these different time frequencies such that we can build a big graph and then solve that flow tracing, this matrix equation. So the first thing that we do is that we convert an event, which is just something happened with a timestamp, into something that also has a duration. So we'll say this event came in and it's going to be valid until either the next event comes in and overwrites it, or that it's too old. We put a validity period of 2 hours. The reason we do this is if there's an event that says now the sun is shining and I'm generating solar electricity, after 2 hours the sun might have set and that data might not be valid anymore. So that's a reasonable assumption to say, even though the sun has set, we still for 2 hours say, okay, there's still sun, it's okay, we still have this approximation. So once we've created these buckets, we can start just chopping up all the events and grouping them in these 1-minute intervals. And we do it at 1 minute because it's the highest potential resolution that any event could come at in terms of frequency. So that's the first step. Once we've chopped all these events in 1-minute buckets, we group them in what we call the state object. So we create this graph representation that represents really the state of the electricity grid at a particular minute of the year. And once we have created this graph, then we can run the flow tracing algorithm. By doing this matrix inversion, what we do is that we switch from a production view to what we call a consumption view. So what it ends up having is the origin of the electricity by going through all the different interconnectors on the grid. And the last step is that from these 1 minute data points, we compute some averages, could be 15 minutes, could be hourly, could be even monthly, weekly, yearly, just to cache them and to serve them to our customers in a simpler way. And that's the output. So the output gives you this connected, this directed graph. It could be cyclic. All the nodes represent the carbon intensity. So green, low value, brown, black is a higher value. And if I just zoom in here on Eastern Denmark and look at the time series, this is a typical example of how a typical week would look like in Denmark. The interesting piece is that you have this blue area which represents hydropower. And in Denmark, we don't have any hydropower. It's completely flat, so there's no way we can have some dams and some hydropower electricity. And we also have nuclear, and we have no nuclear in Denmark. And these two things come from the neighboring countries, Sweden or potentially Germany. So this is the type of results that you get when you do this analysis. Now talking a little bit about the performance and how we implemented this. So we started using Apache Beam. We started using Spark, but we went over to Apache Beam. So Apache Beam is interesting for a couple of reasons. The first is we are running both batch use cases where we're processing several years of data in the past to be able to help our customers do carbon accounting. But we also need to serve real-time use cases such as the app that you just saw before or the forecasts that need to be updated in real time. And Apache Beam enables us to write one piece of code both for the batching mechanism and for the streaming system. We haven't yet been able to use the streaming system, although we're starting to prototype, so we could come back here and talk about it when it works. The second piece is that we have containerized workers. We can bundle up all the dependencies in a Docker image that we just ship off to Google Cloud afterwards. And the next piece is that you can use multiple backends. So you write the code in Apache Beam once, and then you can decide to run it on different places. You can run it on Google Cloud Dataflow. You can run it on actually a Spark backend as well. You can run it on many different places. The advantage for us on using Google Cloud Dataflow is that we don't have to maintain a cluster of machines. We don't need to say we need X machines, install all these dependencies on them. Google Cloud Dataflow will just scale up and down depending on how compute intensive the pipeline is at all the different stages. So that makes it extremely simple to do. And it's also conceptually similar to Spark. So actually migrating wasn't too difficult because conceptually you code it roughly in the same way. So I do not know if you can read this, but this is roughly how the pipeline looks like. You have a first step that I skipped, which is gathering all the information. You have a second step, which is to build these graph representation and chop all the steps in 1 minute, in 1 minute buckets. So this is the second line. It's just a big function that will do all this, but I spared you the details. Then you have this flow tracing step that happens in the middle here. You have the hourly averages that happen here. And then a neat trick in Apache Beam is that we have here to restrict the parallelism at some point in the pipeline because we're restricted the system could not scale infinitely because we have a database that has a limited amount of CPUs. So if this thing just starts spinning up 100 workers that will start writing or reading to the database, the whole database would be overflooded. So we have this trick where we restrict the parallelism by doing a group by item, a group by step, and the number of keys in the group by will be the number of maximum workers that will be able to work in parallel. The idea there is that when you do a group by, you can only have one worker that will take the values of each key for the group by, and so you can't parallelize further than that. So that restricts the amount of parallelism that can happen in this step, and that's really the bottleneck in our system. Which means, by the way, that for the earlier stages, the system will scale up to a very high number of workers, and as soon as it reaches the last step, they will restrict the number of workers to be able to not overflood the database. And that's better than to manually restrict everything on all the steps. A little bit of a graph that shows how this performs. The top graph shows the number of workers. So you see here in Dataflow, it automatically scales up in the later stages of the pipeline before going down again when we are writing to the database. You can see the CPU usage on the second line of all the different workers, and you see there's a pretty high CPU utilization, so the system tries to use as much CPU as possible. And you actually see in the last piece here that the CPU usage gets much lower. And that's actually because we're IO bound by the database write. So there's no need to put like many workers. This won't increase the performance. And you see here in the throughput for each step, where you see that some parts of the pipeline can actually be super quick and super efficient. And that's why we have this immense number of workers that align with very big throughput. Looking at the time, I'll talk a little bit about how we're migrating to new versions every time that we have a new pipeline update. Because we're working with data systems are very tricky to test. You can write unit tests, but sometimes the data changes just by a little bit and can cause some different variations. And so we're always a bit worried as soon as we put a new version of a forecasting system out and like, how do we test this? Will this work? So one thing that we've had a lot of success with is actually to use snapshot testing. So what we do is that we take a snapshot of the input database that we write into a file, then we run the whole pipeline through it, and then we look at the results. And every time that we have a new version that comes out, we compare these new results in order to see visually how big was the system impacted. So something that's useful is that in the pull request, when you have a new version of the algorithm that comes out, you can then see exactly the changes that happened. And at the top, you can see that only a small change in the value happened. But for example, here, you see that the value was converted from a number to none. And that is something that would require a lot of unit tests to specifically catch this very particular edge case. Whereas on visual inspection, you can double check and ask, wait, why did this happen? Did we miss something in the code? So that's actually something that's pretty useful in the data systems if we don't have time to write all these small unit tests. What we do is that we run different versions of the pipelines in parallels when we do some pretty big changes. And then at the end, we have this validation notebook where we compare the data distributions of the output data set. This is one example of a new pipeline that we released a couple of weeks ago, where you see that's a data in Belgium, where we look at the distributions and look at how closely they are, and then we also do visual inspections to verify that the drift of the data is not too big, or at least that it's expected. It helps us pinpoint some suspicious places where we need to double click on. Thank you for listening. If you have any questions, I'm all ears. And I brought some team members with us, so in case you want to talk after, look for me and the boys at the end of the room. Yeah. Thank you. Do we have time for questions? I'll say yes. Yes?
When you are looking at the carbon intensity of something, are you looking at the entire production, like over the lifetime, and are you using it specifically for the company, like, for instance, Vestas might produce a turbine more sustainably than Siemens?
So we do both look at what is called direct emissions. So that's the fuel that is burned in the turbine. So in the wind turbine, you don't burn any fuel, so that would be zero. But in a coal power plant, it would be a lot. We also look at life cycle emissions, which takes into account the whole manufacturing of the wind turbine, the decommissioning, and so on. For nuclear, it's actually also the nuclear waste. But we don't do these analysis ourselves. So we don't get to a level of detail. We can say, this is a Vestas wind turbine that's slightly better than a Siemens. But we use the IPCC numbers, which are quite general and enables for global comparison across different areas. Yes, at the back.
I see that you have divided some countries into regions based on the availability of the data.
Absolutely. And you have some different areas where you have different price zones. For example, in Denmark, we have 2 price zones. The electricity price is going to be different if you're here than if you're in Jutland, for example. And so this enables different data coverage. As soon as the data is good enough, we typically get it in our data based on the open source contributors that help us source the different data sources, yes.
There's also a question online about the snapshot testing part. Can you say a few more words about it? I didn't really understand it.
But do you know what the person wants to know?
So they said they couldn't really understand the concept.
Yeah.
But I guess if you can talk about what would have been the alternative? Did you consider other alternatives?
I think the alternative is to do unit tests. So what you could do is you could start looking at all the different ways your output data could change and write a unit test that says, in this particular situation, the data needs to produce exactly that value, which just means that it's very expensive to get a full coverage. So what we do instead is that you can almost imagine that you're committing an input data set, running it through a transformation. So it could be a JSON file, you run through a pipeline, you commit the output JSON file, and then in a pull request, you would then rerun this process and you would look, my output file, how much does it differ from the one that I checked in, which is my baseline? And by looking at the diff, that gives you an indication of how much you changed your pipeline, and then you can dig deeper into it and look at why did it change, answer some questions. So it doesn't give you the same guarantees, but at least it flags you the places where you should look or be careful. So I hope this helps, but yes.
So very cool project, by the way.
Thanks.
In terms of the big countries, I think it's related to the other question, like France is so big and there's a kind of, then you have influence of wind in some part and the other part, kind of, I guess you're limited by what public data you can get, but is there any kind of way you could build kind of a spatial granularity more into it, because kind of, it was pixels being green or red?
Yeah. What we try to do is that we try to, so sometimes what we can do is when we have limited partial data, we have some models that allow us to extrapolate from it. So there's, for example, some places where we don't know exactly how much the wind is producing in an area, but we know what the total production is. And if we know the total production, we have some models that that break it down into the different types of production based on weather patterns and so on. And sometimes that helps us increase the spatial granularity when we have partial information. But we always need some kind of base data to be able to base our analysis on, else I say we're inventing data, which is too much, right?
Mm-hmm.
Yeah. Yes?
I was just wondering, so when you do the forecasting, what's the time frame you're forecasting, and is there a difference between forecasting year ahead or month ahead or an hour ahead?
So what we do is that we forecast a day ahead, because that is roughly the time scale our customers are interested in. When you think about scheduling a data center, scheduling an electric vehicle, it's typically 12 hours of flexibility you have in front of us. So there's no point in forecasting much longer than that. It becomes much more difficult to forecast a week ahead, because there you need very good weather forecasts, and it's difficult to do better forecasts than just a day ahead. And if you do weeks or years ahead, then it becomes a whole question of modeling the investments. Like the Ukraine crisis shows how difficult it could be, to forecast months ahead. Yeah. Do you have time for more, or else I just continue taking? Yes.
I was curious, what made you choose the 1 minute bucket? Because you could have also gone the other way, since you're anyway only serving the data every hour and set average of that, and I guess you need to backfill or impute a lot of data.
It's mainly because we know we're going to serve higher frequency of data in the future. So it's sort of to be future proof. And also the electricityMap, the live app, actually used to showcase data that was the freshest. So we wanted to have data that was potentially just a minute ago. Now we actually show hourly, but that's something that we're going to improve. Yes?
I noticed that there were no governmental clients, but I noticed that there is a natural candidates, right, for this. Do you have a reason why? An insight of why?
So we have non-governmental agencies. I mean, we have like the OECD, who's used their stuff to publish some reports on state of decarbonization on different countries. Governmental agencies typically have a more local focus. So for example, in Denmark, you have Energinet, publishes roughly the same data with different modeling techniques and so on. They will be focused mostly on Denmark and won't look at the influence of other neighboring countries. And then there's also a political angle to it. If you want the whole story, actually in Denmark, we're very happy to showcase the wind potential that we have. So therefore, the assumption I just had before explained that electricity that you export, you cannot choose selectively what you export. The rules in Denmark are actually that you export dirty stuff, that you keep your local production predominantly. And that of course shows that we're greener locally because we export the bad stuff. So these assumptions always end up being political debates, and that becomes a bit tricky. So sometimes it's just, I don't know, governmental agencies haven't been our best friends, always.
Super, thanks. I think if you can stick or after
Yeah.
the second presentation, maybe you can ask more questions. Otherwise, your contacts are available.
Yes, absolutely.
Thank you.
And we're also hiring, so if anyone is interested. But I guess that's just a recurring theme of this. No?
Starting with the next session, if you want to get the drink, then have a seat.
Okay, let's get started then. So the next session will be about data mesh. There will be almost no technical slides at all. It will be principles, architecture, domains, some kind of stuff about that. So, but I still hope that there will be some kind of still bricks, different pieces that will be put together. If there are any questions, then let's keep it to the end, because I hope there will be a lot of different dots that we'll try to connect throughout a couple of slides. So just shortly, my name is Anders. I'm head of data platform and AI in INTELLISHORE. Been a consultant for 8 years or so, and happily joining all this, and great not to be online, but actually being here in real life. Just very quickly, INTELLISHORE, 45 people working with people, data, IT, everything. And we are tech agnostic, meaning that maybe it's even my job to figure out what technology we should use and not to use in the future. So just a broad picture of that. Always trying to keep in mind that there are people involved in everything we do. So don't be the consultancy where you be there for 1 year, be the consultancy where you are there doing something for 3 months, get out, and the company should be able to do the rest of it. I think that's it about that. And hopefully maybe one question, we are hiring, but one thing that I want to point out still is that maybe this is actually one of the answers why we shouldn't hire more data engineers. Let's see if that's the truth at the end, solving a lot of problems for anyone. So I guess that everyone, okay, let's just start with one question. How many knows around or heard about data mesh? Okay, there's actually not that many I thought of. How many did heard about it a year ago or something? Almost thinking. Okay, so for me, data mesh is something that just popped on LinkedIn all the times. Everyone is speaking about it. Really few actually is doing something. I have done one project about it. We are starting up a new project now at another client, and I think it's something that we need to take down on earth. Actually, what is it? What do we do about it, and why is it actually there? So let's see that for the next slide. So everyone kind of know this. We heard that the CIO presented early on that we have this platform. We try to have one platform to rule them all, getting all information, unstructured, semi-structured, structured information into this big Hadoop platform a couple of years ago, now this big cloud platform, and then some new innovation inside reporting analytics will come up. And we have seen various different generations, so maybe that's 20, 10, 5 years ago or so, like that. Everything more or less the same concept. It's the IT department who is in charge of all pipelines, definitions. Everything we do is that, okay, sales need something, I need to talk to the salespeople to understand them well. When I understand what they're doing, what they're asking for, I will take all the knowledge and try to set up some pipelines, make it through, and within 3 months or so, they have something which I hope is on kind of the same page as what they were expecting. But there are some big issues about this, and I hope that will be lighting on later on here. So data mesh in a nutshell is a decentralized SEO technical approach in managing and accessing analytics data at scale. So this is only analytics. It's no transactional systems at all. It's only analytics. And be aware of the SEO technical thing, because this is really, really much more about organization and people, and really, really less about the technology. Even that throughout all the papers, all the articles you read, you will not read any technology's name at all, more or less, if you go through it. So if we move a bit on to here, so we have these 4 principles. That's actually what data mesh is trying to see. How can we do it? Why do we do it? First of all, I will run through all of them with some few examples, and I hope that many of those would say, okay, we are already doing that, or maybe you should do that a bit more. But it's a domain-oriented decentralized data ownership architecture, data as a product, self-service data infrastructure as a platform, and federated computational governance. Many fancy words, and let's move on to some of these. So the first principle, that's the data domain. So at the moment, everyone here is, you have the IT department, which is taking all the needs, all the orders, new reporting, whatever is done, and then we will try to handle up. And the thing is that we are hiring everyone because we are kind of the bottleneck in all this. So we are not many people, and at the end we are no kind of, it's not like we have 10,000 more people next year. Maybe that's even a bigger problem for the kind of the people asking for new data analytics and setup. So what we're trying to achieve is that taking out this BI analytics department, take one guy from each, put it in each other domains. So you actually have sales and data engineering in one team. You have your manufacturing departments with a data engineering. So the data engineering that we know today, the teams, the analytics, the data platforms have been split out in different domains, which means that we actually move not the knowledge and the code or everything we know to the people who are actually needing to convert all these things to code. Now we're trying to move the brain, the data engineering, close as possible to the data. And that's a big new change of all these things. But one thing that actually arises when we do things like this is that we are now creating data, and you can maybe look at this as various platforms. You're creating data here, over in the logistics department, sales department, everything else. And that's actually a bit hard. So that's more or less, you just add it up in different silos in your company. So what can we do about that? And we need to figure out a good way to make sure that we have a right quality and everything in place for doing so. And the second principle here is data as a product. So that's the one. Data as a product is kind of simple and something that everyone in here should be doing every day. We should be really, really proud of all the data that we collect, that we analyze, and that we present. We should really care about that the quality is on the right level, that we understand everything, that we make sure that all the data can be used for everyone around the world, and then could trust these kind of information. I'm not sure that's really the key everywhere. We actually, maybe it was one of the first times I saw some good example of how we actually comparing data when doing migrating, updating of other stuff, but we really need to care about this as it was everything else. And maybe a good example, if you're familiar with Snowflake, Snowflake has this marketplace. Out there you're paying money for getting information and data from various other data companies. If your quality is, if the data is not updated, if the quality is bad, if the documentation is not right, then no one would buy your product. And that's why we trying to add these principles within this setup, so everyone is keen of actually making everyone else in the company using your own data. That's one of the main reasons for this, doing so. So seeing this as you're selling a product, you need to really take care of it. You're sculpting something in glass, you will put it in the window at the front, and you're really proud of it, and you want someone to pay 1,000 million for that product. That's how you should look at it, and that's how everyone should look at it today, even you're not in a data mesh while doing so. So next slide is to make this work. We need a way to not having 10 different platforms, need to build them up from scratch, infrastructure everywhere and all this kind of stuff. Actually, data mesh and the core is not saying anything about technology, as I said before, but we want something that we can easily and spin up whatever is needed. So I said that one domain is doing some streaming, another one just doing batch. They need not to go out and do everything from scratch, because as we know, we can actually learn a lot from each other, and that's why we sometimes centralize things instead of decentralize. So if we could come up with some kind of idea, some kind of platform where you can easily go in as maybe a layer on top of your cloud platform, where you could go in, now I just need this SQL server, I need this streaming function, I need this blob storage, whatever it would be. That's an easy way of doing so. If we can put even a layer on top of that saying, now I need to do ETL, then 5 different things is set up, the network is completed, everything is working, now we're good to go. That's the way we want to end up this. And one of the other reasons for this is also we're trying to get down maybe the complexity of what we're doing. So I think there are many clever people in these rooms which can do a lot of great stuff, but if we are moving the things that we're doing closer to the business, and then we need the business to be able to understand what we're doing, and we need them to help us doing this kind of work. So 20 years ago or so, people were talking about self-service BI, doing your data in here, and then you're moving the BI, the reporting, down to the business. We did that because we wanted the business to create the product by themselves, and they were the one actually knowing what to look for. When was this correct or incorrect of the data? Kind of the same idea with data mesh. Now we're actually just moving the data pipeline as well. So could see that we're going one step back in the chain of the data to take it. Well, we just need some kind of setup where it's easy for people who are not in education in doing IT for 5 years, but they can go in and help in doing so. And I will come up with some example of that later on as well. So that's kind of the cognitive leads that kind of need to go down. So we need not developers, DevOps people, everything, but more or less some generalist people who could go in and help us with these kind of things. So the last principles of these 4 that you saw at the start is the governance. Because one thing that everyone maybe is been thinking about, we're a bit always concerned, is data governance and just governance in general. Are we in control of who's looking at what data? Are the data actually allowed to be where it is? Is everything updated? All that kind of things that we kind of try to forget, but you always know is there. It's something that especially need to be in place for this setup. Because when you're having, let's just be honest, kind of data silos everywhere, and you're the company, I want to merge or correlate some of these information, we need to have some common standard of what is actually a key identifier for our customer, our product, or whatever it be. How do we document? How do we make sure that people can find these kind of informations, and so on. So I think this is maybe the hardest part of doing all this kind of stuff, is figuring out that now we're decentralized, all these data products, the teams, the infrastructure as well, pipelines, and now we need this centralized setup where there are some connections down to all the domains doing the stuff, making sure that we have some kind of standard so it's not too siloed when doing so. Yeah. And if we look at kind of seeing this maybe as a house, the first that I presented was this data domain. You have this logistic, you have this transport, you have all this as you always know, been microservices that people invented 10 years ago. Maybe look at this as some of the same things that you have all this microservice you're really proud of, you're having these things, and then you're developing some data product that someone else wants to use out there. For doing data domains that we had before, the departments or the companies, the product that you're trying to sell out in the rest of the organization, then at the bottom of all this you need some infrastructure, you need some technologies in place, being able to do all this stuff. And at the end you have the governance taking care of all these things that need to be in place. So I hope that kind of you see that going from a data lake, that doing this decentralized work of putting all the data engineers to pipeline in different places is really a hard thing, but trying to capitalize everything in the governance and adding this as maybe a service from the infrastructure department, saying what kind of technologies you're allowed to order when, trying to capitalize most of the things in here. And as mentioned, a lot of slides and a lot of non-tech, no icons, no clouds, no everything else, but just saying some principles or some guidelines. So I'm the guy actually looking at the tech, and now I actually understand what they're trying to do and what they mean. So this is Microsoft's way of looking at data mesh. So you have all your data domains, logistic, sales, whatever that could be. You have a way to share your information across your different departments. You have your platforming services around. We can actually use EDF, SQL, Databricks, whatever we want to use. And then at the top of it, you have purview, you have your security, you have policy rules and everything that try to make sure that no one here is just messing it all up, and that we actually can use the data across the different teams. Another way of looking at the same thing, again from Microsoft, more or less the same idea, having the different technologies out there. As you see here is a bit of mesh of something suddenly using the Hadoop. Not sure why, but there are different technologies which make sense for the different places around the company because they have different needs and why they are using so. And this is what I'm doing now, or have been done for quite a year. So I'm pretty sure that many of you would look at this and say, okay, Lakehouse, Databricks, we have something staging, or we call bronze, silver, curated, gold, whatever terminology that you're using. We have some ADF compliance getting data in, and that's just the normal way of doing so. But the main thing is that up here, which we at this point in time is calling a project room, meaning that this one is being created by Terraform. You can go in on the homepage, say, okay, now I need this developer, this project room. I need these 5 technologies. When this has been created, also need these 5 different data sets. Everything needs to be in place for me to do my work. So this is something that is non-existing before you ask for it. It will be destroyed within half a year. That can be 1, that could be 100. We don't know. So making sure that we have the core here, where the development can happen up here, but the core where you can store your information, that could be your pipeline, can be maintained, but you have this at the top of it. So think about it as a homepage running Terraform at the back end, spinning up all this need that you have. For Power BI, we have machine learning, and we have, it's not that updated, but ADF and the common tools, Databricks, and so for this. I really recommend going in and look at Flexport, which have done a webinar with, I'm not sure if it actually was DBT, but they are a really cool company, have been looked into. The problem was we need more data engineering. What could we do? So they look at data mesh and are changing the thing. And maybe that's one of the fun things about when we talk about lakehouse, data lakes, data warehousing. There are of course different principles if you're using Kimball or something else. But in this data mesh world is so new, so there are many different flavors of what it is. They took the decision that everyone should use Snowflake and dbt for using the work. So imagine that spinning off Terraform, all this stuff. This is you need to do your work in dbt and Snowflake, which of course will give you big advantages. Instead of having a blob storage, you have your SQL somewhere else. It will all be maintained in the same place. So I'll share a link of course to it, but it's a really good setup for thinking so. I think that's more or less you need to go here because otherwise you'll end up having Parquet files, org files, CSV files, SQL servers, Cosmos DB, everything else in the same place, which at the end will be quite hard to correlate across the different domains. But why are we actually doing this? So back to maybe the question before, there is a lack of data engineering all around the world. If you look to the US, and if you talk to some technology vendors like dbt or someone else, you actually be quite surprised that the background for those people are not IT, they're journalists, they are chemistries, they're different things, but they just have the tools and they were quick learners, so they could come up and get these new skills on board. And this is just one of the examples that we have a huge problem, not only in Denmark, but I think more or less around the world. The number of complexity, the data, everything else growing. Number of people having the skills to do so, not so much. So that's one of the things that we try to, if we can take down the complexity of this, putting out to the business, actually leverage the people power that we have in the domains, then we are more covered to the future. So I hope that this sort of makes sense, that this is not about technology at all. And I think this is really hard to implement, because imagine that you have your good old departments that you go up tomorrow on work, you will be sitting with your colleague doing data pipelines, and then some point of time the CIO got this idea of doing data mesh, then everyone will be put out in different locations, and now you have to work in that. I think that's the organizational change of doing so is really hard, and something that many startups are better doing because they are more flexible and can see some of it. But in bigger companies, this is something that needs to be taken seriously, definitely. And I actually, by researching a bit of this, I really like this thing of, while data for most may not be a product in strictly economic sense, it is still the lifeblood of the organization decision making and should not be allowed to become a byproduct. Again, if we look at data as a product, we need to take this seriously. We need to make sure that we have the quality documentation, use of it, making everything as we were really proud of doing so. I think that's sometimes it's really forgotten in companies that we look at the sales, but we may not look at if we could invest more in the IT or the architecture, the structure that we have to even grow on the future point. Just a bit more. If you're more interested in data mesh and some of the technologies, I'm having a tech talk with dbt Snowflake the 6th of April, where we will talk about how we did it with Snowflake and dbt. So free for everyone to join the webinar if you want to. And that was actually it. Thank you. Did it make sense? Sort of?
I have a question. So, for example, we are about 90, 100 people in engineering product, but also combined with data. And I'm just wondering at what point, because we looked at data mesh and we are like, we might be a little bit too small and we might be doing well with the centralized uh, data platform team. So at one point, in your opinion, do you think it's good to adopt the data mesh concept? Because to your point, it's not necessarily about technology, but it's also the.
I think I kind of overheard the company that you were working for, and for me it's a really focused company on IT and data, and I think data mesh is more relevant in a concept where this is not an IT company. I'm not sure, maybe banking would be maybe a good or bad idea, but if you're looking into pharma, for instance, so really specific of knowing about the product that you're doing, and if a data engineer should take all that knowledge and knows about some chemistry that they're doing which they don't care about, don't know, maybe that's a better setup. But if you, as a personal opinion, if you are a company with half of the staff is technical people, then data mesh is not, there's not that many people to actually move around. Maybe you're just enough people to do so. But having a company just in number of employees with 100 or 200, I don't think that's this is the setup you want. You need to go to 1,000 people or more to do so, because you need to have some kind of scale where you don't know what everyone is doing and don't know how sales is operating, maybe across the cloud and so that's, yeah. I think there's many personal opinion about that, just to make sure that I'm not the one invented it, but yeah.
But there's a follow-up kind of question also from the online, which is, Dimo is asking, does it work if you have a smallish company with 2-3 data engineers? There's no value in it. That's your answer. Short answer.
Not in my opinion. There needs to be some kind of scale. There needs to be some kind of sizing. This is not for fun. This is where you come up as a big you don't have enough data engineers. There's the knowledge is so specialized that you need to have someone who is responsible for some sort of area and just the go-to guy of having. So I'm quite sure that maybe you're doing pipelines and data product or BI reporting, and then you are kind of the specialized people, that the go-to people when the HR is coming for a report because you have done 20 of those before. It's kind of the same idea, but just pushing you out to the HR departments. Down there?
Yeah, I understand the idea of data mesh, and it's kind of like benefits. Makes sense to move engineers towards business knowledge rather than the other way around. But I don't understand how using data mesh will reduce the number of engineers. Shouldn't it be my common sense, like it would be the other way around?
Yep. Okay. Some of the reason why is that the knowledge that needs to be shared from a centralized setup, there's a lot of knowledge, and to different people they need to understand the same thing maybe because you're on vacation, someone else. Then having a specialized out there will build up the knowledge and the relationships to the business. Another thing is that you want to have some kind of setup where you can take your own decision. As a consultant, I'm really in a lot of different companies where adding a new technology, doing a smaller change to your architecture needs to go to some kind of board and be approved, and not only 1 quarter that it will be done. So there will be some kind of autonomy that all these domains have their own, as a data mesh principles, you can choose whatever technology which makes sense for you. It's not a global thing that they say that they will ask, but pushing out.
But that brings up another problem. Like the whole idea of data integration, data warehousing, even data lake came because of the problem you were talking about, like data marts. They're operational data stores. They answer specific questions. But at some point, businesses need to ask questions across their business, which data marts cannot answer. So you can bring some kind of autonomy. I don't think it will reduce the number of engineers, but you're also in a situation that you cannot answer questions that are like that you need to some kind of integration. That was the whole point of data warehousing and even data lake. So even if you create autonomized teams, you will still need data integration across your organization. You cannot escape that.
Yep. I agree. I don't think there's a yes or no answer to it. The idea is to also make some of the technologies or the product that you are creating, that taking the salespeople actually scale them up to do some of the stuff themselves by making it more easier, the skills level, the cognitive level of what you have to being able to do so is also one thing that I try to solve out here. So maybe if you're working with a sales guy for 5 months, then I'm quite sure the sales guy would be better at, maybe you used a lot of your time to actually scaling him up. I don't know, but I agree on it. I think also data mesh, I think there is a tension that everyone tries to centralize things, and then 20 years later on, the new thing is to decentralize, and then you go back and centralize. There is a back and forward all the time, so things that as self-service BI, not seen that even working perfectly at any company yet, but that was the hot thing some years ago, maybe not that hot today, but fair point. Yeah.
Yeah. I've seen that failure mode where there's a data engineering department in a big organization that just tries to own the pipelines in the beginning, and they just get swamped, and that bottlenecks all the data initiatives in a big organization. Now the solution there seems to be that, okay, well, we train those data product owners, right? And I'm just wondering which skills do you then have on those data product owners? Because to me these again sound like unicorns in a way. You know, there's like very deep domain expertise, but then at the same time people being able to use whatever snowflakes and being comfortable and using DBT at the same time, while at the same time being able to explain the data products they're owning to people across the organization. So what skills do you usually have?
I agree, you need to be some kind of specialist. Being the guy who actually was studying pharmaceutical things and then have a flavor for IT, and then you get this unicorn mix up. Of course that will be the best person, but that will not be the majority of people in the data domain team of working. So that will be the one guy who may also be the one representing at the governance level, but you have if I can just go back 2 seconds. Data domain owner who's representing all this. How do we have the governance standard or some of the things? The rest of the people in the data domains departments may not be that unicorn as you mentioned, because you're having a mix up of IT people and business people having kind of mixture of those together. But definitely this is a hard job of understanding, being the best one understanding the business, being the best one understanding actually IT maybe as well. And yeah, we need those people around the world and in the teams. So what kind of skills? Yeah, I think it's dependent on the situation. I think what's at the back.
I think it's also a bit of the assumption that we're doing it because we don't have enough engineers. I would say that it's more about we know from our history that pushing decisions down to where decisions to the front line and shifting left leads to better outcomes for our business. So, I mean, I'm sure everyone's been in a position where you do some analysis, you find some data that's wrong, go to the data warehouse, they say, oh, right, that looks wrong. They have to go find whoever sourced the data, and then until that data gets fixed, it's a massive loop, and every handover, we know from experience, causes extra costs. So let's push all that to the left so that people making decisions about the data are the ones who are the most competent to make decisions about the data.
That's moving the data engineer as close to the domain, and then we have the developing of the pipelines doing people sitting on top of the data as having the knowledge. I'm working as at a newspaper today as a consultant as well. And if I had the job to validate the number of click doing on a homepage, I'm not sure that should be 10 million or 20 million or 500,000. I don't know. I need to add that expert to answer those questions. And if that is in the same team, at some point of time, I actually have the knowledge to do so. But yeah, great view. Yeah.
Kind of a few years back I read a white paper on kind of on this decentralization, and if you put people out like the attrition rose because you didn't have the community of common other data engineers, you would feel lonely and you would find somewhere else. Kind of just I don't know much about this data mesh, but kind of, is there any long-term experiences? Have you done? You seen that where it kind of it's been implemented and people still kind of happy? Or
I've, not in this world, but if you look at the BI world, you having this experts sitting in different places in different departments, and they are the one developing the reporting for the HR, for instance. As a colleague been scaled up to do so in Tableau, Power BI, whatever. But they will again they will feel lonely, and they will need to also be aligned of what they are doing elsewhere in the company to follow some kind of guidelines. So what we're seeing is I have seen is that you set this center of practice up. You have your COP meetings where you meet every second week, where you can share information, knowledge, and insights of doing so. And I think that some of this setup, I think there's methodology like agile and full stack teams and center of practice or whatever you call it, is trying to do some of the same things. We're trying to find this sweet spot between completely decentralized and completely centralized, and every company is a different species, and so. But center of practice is something that I have seen and are seeing today, and set out to try to solve some of those things.
Hannes, let's do one more question,
Yeah.
one or two.
Yeah.
One or two.
And then we
Okay.
should feed the people.
Yes. Whoa. Yeah. I had up before.
Just curious about the governance. It says federated computational governance, and I was just you have not touched so much on the governance part, and how can that be different from kind of any other setups? What is different in data mesh compared to other setups? So if you could just explain a little bit more about the governance part.
I think that when people talk about governance, or we have been asked, how is your governance, how is it set up? This has so many variation of what it actually means for you and I when I say it. Normally everyone will say, oh, data quality. But within this, there will be, the idea is that you have a centralized set of kind of agreeing on what standard that we set, agreeing on the things that I said before of being able to correlate the data afterwards when doing so. But you also have this data domain before people actually participating in the discussion of the documentation of your information. So everything that you know from the data governance world, the documentation, lineage, quality, different standards, everything's trying to add that up in a board where you have a representing of people from the data domain as well to agreeing on some of these. So I think that's the most fluffy thing I could answer maybe, but it's also kind of how it seems. But I think just own experience again, governance, data governance is so different for whatever people is thinking about it. But when they say federated, is to add up all these data domains or data domains owners into the kind of maybe a cup or something similar to share the ideas. So, yeah.
You need a central authority to maintain the governance, so organizations doesn't step on others' toes.
So once again.
So do you need a central authority to manage the governance over data mesh, or just so like the internal organizations doesn't step on each other's toes?
That will be one of the things. It's to have this thing working. We have to kind of agree on something. That's our world. That's how we do things. That's how we store things. That's how we set up. Again, it's the same thing as just one data engineering department would do. We need to agree on what is the naming convention of our table. How can they be accessible? What is the policies of everything from access to just the set of it? So that just needs to be centralized. Otherwise, it will be silos everywhere. Okay.
I think we need to stop here with the official presentation and move to.
Let's give the hand to
Yeah.
Hannes. We need a few minutes to set up food. In the meanwhile, grab a hold of Hannes, grab a hold of Olivier, he's also here somewhere. And then we'll have food over there in front of the room in like 3 to 5 minutes.